Yeah, I think we can get started. All right. So I remember a few weeks back, someone mentioned that we should take notes. Um, so I'm gonna ask someone here can help with that. Just capture bullet points of everything we talk about. Um, we don't even have to capture bullet points of ideas we come up with, but simply just large questions or themes for the day, and whatever we decide based on the questions we ask. um, because that should give us enough of a start, like that should be enough for someone to go back and search, and maybe go using keywords, they find out which days which meeting has a particular topic, and then they can go to the YouTube video and get into the details. So who can I ask here to help with that?
I'm usually not sitting down during this meeting. It'd be hard
Hmm.
for me to do it.
Uh, so I can do it for today, but next week, I don't know. Maybe I won't be joining.
Okay. Okay, we'll start with that then. Thank you, Jiffin. So, if you can just capture, like I said, the overall topics we discuss and any
Hmm,
decisions we come to. That's all.
sure.
Thank you.
Uh,
And I will share the document with you. Um,
hmm,
so the document that we use is the pinned document on Six Storage Cozy Slack. I'm gonna share it on this meeting chat. There you go.
hmm. Okay, I can update the doc at the end, right? Like
Yeah, you should.
after,
Yeah,
I can keep it a separate doc and put it
sure,
like
sure.
yeah.
That'll also work. Yes.
Okay.
Okay, so let's continue where we left off last week. I think last week we left off talking about workload identity based authentication and authorization. So we were talking about how the overall concern we were dealing with was what was required, what was left to be addressed in the KEP. And Tim's major concern seemed to be uh, how we were going to solve workload identity based authentication. That is, in cloud providers, IAM allows an identity to be attached to a particular workload. So if a particular pod or a particular deployment or a particular node is making a request, then by default it's assumed to be authorized as a particular account, a service account. Um, and we wanted to figure out in Cozy how we'd enable that for pods. So our answer so far has been, um, there'll be some backend mechanism for cloud providers or Cozy drivers to associate a particular pod with a particular identity. So we will not get in the way of that. We will just say, uh, the driver is free to do it whichever way it will. Um, and all we'll do is we'll mount a token associated for that IAM account, or either a token or some other thing. I don't know what I would call it. It's most
Well,
likely
in
into
the
the pod.
case of a cloud provider,
Mhm.
the token's already mounted. It's somewhere there in the pod already, right? So what would be needed in terms of our downward API would just be a notice to the underlying app that that is what it should use, right?
Here
But
here is. Mhm.
my big concern in all of this is that, like, if I want to write a workload that's portable to on-prem and in cloud scenarios with Cozy, there needs to be a way that I can write one workload that sort of just finds out based on where it is what it should be doing and then do that thing. So if it's in the cloud and it's going to use token based auth, we should have a way of signaling from Cozy down to the workload, in this environment, use the token. But then when the very same workload runs in like an on-prem situation that doesn't have a token and it's just access key secret, like then there should be a way to signal, like, in this environment, use the access key secret, and the workload should just run, right? It shouldn't care. It just wants to use the S3 API or the GCS API or whatever to do its work.
So for this, I think we said we'll allow the workload to say the exact kind of authentication that it can use inside the bucket request.
But it's inevitably going to be a list.
Bucket access. Oh no, so the list would be on the class side. The bucket access class would allow the list. It'll say these are all the allowed
No,
ones.
but that's the opposite of what we want, right? What you want is the workload to be able to run anywhere, which means it should say, I support all of the authentication mechanisms, and the bucket request doesn't care what kind it gets because you want it to run in Google Cloud and you want it to run on-prem.
Yeah, so we talked about this last week, and the person from Google Cloud was also saying this. A workload, yeah, the SDKs currently that are shipped with every cloud provider, pretty much every object storage provider, does allow for multiple styles of authentication just by default.
Yes.
But applications that use these SDKs may choose a particular one, and that I don't know if that's the most common pattern, but that's the thing.
The cluster admin or the sort of the operator that installs all this, he gets to decide what he's going to provide in his environment, right? Like if it's GKE and GKE has the built-in Google Cozy driver someday, like Google may decide that everything's going to be tokens. You're not going to get access keys and secrets as long as you're in GKE. And that could just be how they set up their bucket classes. And this, you know, as long as your workload is compatible with that, you can run there. But if it's not, you're out of luck. And I don't see a problem with that, right? Like then it's just, if you want to run in GKE, you support the Google tokens as a way of doing it, you know, or you use an SDK that can do that. And it's just, and then your workload just becomes portable. You shouldn't have, the moment you have the application writer or the workload author saying what he wants, then he's tying himself to a particular implementation and losing portability.
Okay, hold on a second, because I thought we discussed this last week.
We did. We're trying to continue that conversation.
Okay. Okay. Go ahead.
Yeah, I thought first, and let me know if this is correct, Ben. Our definition of portable means it's not the same as PVCs. Our definition of portable means that the client application has set it's bound to a client library to communicate with a specific object store. Is that right?
No,
Object storage protocol.
I'm actually aiming for something very similar to what PVCs give you, which is it should be possible
that's not possible.
Well, I don't agree. I think if we enumerate a list of authentication schemes that Cozy may give you, and you have a client library that can consume all of those, then it's just a matter of telling the workload at runtime which one it's being given, and then
but that's a ask first and then it's not really the way Kubernetes works. The way Kubernetes works is it's a try catch model, right? You could say. So you have to tell your you deploy your application with a request, and then you're told the backend storage system you've chosen does not support this or something, right? So I thought we did, like in last week.
You're saying that's how it does work, or that's how it should work, or
that's how it works in PVCs, like, you know, or things like that. So anyway, what I'm trying to say is, I thought last week.
But there's the lowest common denominator version of PVCs that just works everywhere.
No, we talked about rewrite many, I think. So Ben, I think what Lewis is saying, and this is what we discussed last week, which is
I vaguely remember last week.
Yeah. So we specifically choose what kind of authentication model we want, and if you know the admin is responsible for putting us in a different cloud that also supports the authentication model or different object storage system. So that's what is expected. If you're expecting to change the authentication model, that also changes guarantees that the application expects. So I would think that's acceptable. Where if you move from, say, one style of authentication to a different one, the application should know about it, and application should particularly ask for what specific authentication model it wants. So if it says I want token based, then I can move between two
Right,
providers that allow token based.
but
Or
what if they want access key secret
Wait, so
and
let,
the
let
admin
me
doesn't want to allow that?
well, let me go back to what we discussed last week, because I think it's solved. I thought it solved this.
yeah,
So the stores class has a set of guarantees, and in them it has a set of approved authentication models. The driver can, through the same way CSI does features, the driver can say, these are the authentication models that I support, right?
capabilities.
Exactly. And then the requester then says, I want a bucket from the bucket class, this A, right, which has the correct authentication model that I want, right?
Yep.
And then that bucket is then provided, and that's how it should work. In other words, the requester knows what type of authentication model they want. The admin sets that authentication model through the bucket class, and according to the driver spec, and the driver can then identify if it does support it or not through the spec itself in the gRPC communication.
Yeah. So Louis, I'll explain Ben's concern.
Yeah,
So we're saying that it breaks our previous definition of portability. We had defined portability as if you have the same data protocol between two providers, then I should just be able to take my definition, like bucket request definition,
sure.
put it to change the bucket class, and it should just work. That was the idea.
Yeah,
But
and
now
that
definition of
should still
portability
work.
is changing. Mhm.
Well, no, I'm
Um,
saying I think that still works, right?
yeah, because if we define the authentication method in the class, then yeah, it should work.
Yeah, I think that still works.
Yeah,
Does this not work what I described or not?
like I said, with
So
that authentication method in the class. Yeah.
Well, that's
Uh,
up to the admin.
yeah,
That's
yeah.
right.
right, but if I so I didn't follow that 100%. So please humor me.
Okay,
So if I have two clouds, one of them is running in GKE and it only supports token-based authentication.
sure,
Then I have another one that's maybe using like OpenStack Swift on-prem and it only supports access key secret.
sure.
And now I want to write an app that it can seamlessly move between those two and just work.
Well, you can't seamlessly move between the two because your app is going to define the access model.
Well, but that's what I'm saying we shouldn't do. Like it should be possible to define an application manifest in a container image and all of the things that it just, regardless of which of those two clusters you pointed at, you will get an acceptable result.
But how is that possible? You have a token for one and access key for the other.
If we define as part of our downward API some information that gives the pod, tells you which one you're working with, and if the S3 client library that is actually going to do the heavy lifting just supports both, then you really don't care, right? It's like you're going to get one or you're going to get the other. The client library can deal with both. You need maybe a little bit of handshaking to figure out which one you've got, so you can feed it in the right format in. But that's just like some init container or some simple logic on the front end.
Let me just break down what you just said. So you said that the client has one way of doing it, and that the library supports both. Is that correct?
No, I'm saying like
client can use either of the methods supported by the library.
That's
yeah.
So
yeah,
what I'm trying to say,
the library might have a list of 3 or 4 or 5 different ways of authenticating, depending on what you hand it, and so it's flexible, right? And so what our job is to plumb something down into that pod, and if the pod can consume any one of 5 different authentication mechanisms, then we just have to make sure that what we plumb down is one of those 5 things, and we tell you which one it is, and then.
But Ben, yeah, that's true. Yeah, we have to plumb down one of those 5 things, right? But who requests it? It's the application, right? So it's
But
a
the
3-way
application
contract.
just wanted a bucket, like, and it
No,
just,
no, the application
and it
also
wants
has
to be portable.
No,
Well,
wait,
no,
hold on. I just
Mhm,
want to just
Mhm.
go back to what you were saying, because you mentioned that an application had, let's just go one thing only. It supports only access and key, right?
No, in my example, a particular Kubernetes cluster might only support secret key, access key, because it's using OpenStack Swift and it's not running in a cloud, right?
Okay.
So it could be a feature of the cluster itself that there are no tokens, there are no, I forget the other authentication mechanisms, but you might be in a situation where the only thing available to you is access key, secret key.
Sure.
Because you're in some on-prem cloud using some implementation that's fairly bare bones.
Sure.
And my argument is I should be able to write a workload that can just cope with that if that's all it's given.
I think we had to put the pain somewhere.
Not even the pain. See, I look at it as we're orchestrating it, and it should be represented somewhere.
I say we should put the pain on ourselves, right? That for Cozy to be a valuable API, it should do this work for you.
Okay, that's a good point. So let's draw the boundaries of where this goes. So there's a 3-way contract between the driver, Cozy, and the application here.
Yes.
This is not like PVCs and PVs, because in PVCs and PVs we always assume it's POSIX. So we don't care about the contract. It's set in stone. So coming here, what all options can someone specify in a PVC definition? Not in a storage class,
right.
but in the PVC.
You can specify the volume mode, which can be file system or raw block. You can specify the access mode, which is a list of potentially RX, ROX, RWX, RWO, and RWOP, which is the 4th new one. And you can have a list of one or more of those.
But that, again, it's not super portable, because
exactly
but RWO and file system is pretty portable.
No,
like
wait,
you're right. Raw blocks.
Hold on.
It's not 100%. Yeah, go ahead, Luis. Please.
So if again, I'm going back to the application. If the request from a PVC requests a raw block, and there's no raw block provider, you will pend, right?
Yeah.
And that's what I'm trying to say. There is a request from the application, so the application must change. There's nobody providing a file system as raw block. That's what I'm trying to avoid. I'm trying to avoid this glue in between.
So I totally agree that there's some less common ways of doing things with PVCs that if you request them and they're not available, it just breaks. But there's also a solid core of RWO file system volumes that are going to work in 99% of cases.
Well, we can't do that. We can't check. You can't pick cases and things like that. We have to be clear, right?
Right. The other thing is, if it doesn't work 100% of the time, it doesn't. Even if it's just 1% where things don't go right, I don't think we can make the case that most of the time this works, so that's okay, but not here. So coming back here, a guy brought up something interesting on the chat. Guy, do you want to say it?
Hey, what's up?
Hey, long time no see. Welcome
yeah,
back.
Sorry. I was on vacation, and it took me time to wind up back. So I just want to say I think Ben's direction makes sense to me. I mean, if there's the authentication method, which is what you guys are, I think you're discussing mostly authentication, right? You're not talking about anything else at this point.
Yes, for S3 specifically. Yes.
Well, no, we're talking about not S3 specifically. What we're talking about is workload identity based authentication, like IAM style. Currently, we have a method to orchestrate access keys and secret keys all the way into the pod. But if we wanted to do any other style of authentication, Cozy doesn't have support for it. So we're talking about how we would do IAM style authentication. And what Ben is saying is, given that we're going to have more modes of authentication, and the contract of authentication is between the application and the object storage provider, So we have, we're trying to figure out who specifies what kind of authentication mode they want, and who says these are the modes that are allowed, or these are the modes that I support, and how does it affect portability?
And my argument is we have an opportunity for Cozy to define a minimum set that all workloads have to be able to consume. And then if we can successfully do that, then we have portability sort of for free, right? We can say,
Don't
some
we
might
have
give
that as
you
access keys and secret keys?
We're not inventing it. I mean, we just look at the SDK, right? I think the portability that Ben's mentioning is that it's not that the application has to be aware. It doesn't even care, because what it does usually when you write an application to an object store, you just take the SDK and the SDK loads whatever is in the environment or the file configurations, and the application itself doesn't do anything for that. It just loads the SDK basically. So now we're saying it's true that if you take the application with the SDK, you can say it does care, but it is flexible enough to load a bunch of methods, and
yeah,
that,
the only issue. Okay,
well,
so
and the argument I'm trying to make is access key, secret key does in fact work everywhere, but like if there are certain environments where people are going to say I will not allow that because I don't feel it's secure enough, and I want people to use my tokens, like we could view that as a purely optional thing, or we could treat it as a mandatory thing. We could say, look, we're gonna give admins the option to require that, and we're gonna say workloads just have to deal if that's what they're given. And we could sort of draw the line there and say that for a minimum bar, you have to be able to accept either A or B, and we can append C, D, E if we want. But like we can just say everyone has to be able to take at least these two or at least these three, and then from that comes a lot of flexibility and portability. If
what is the reason not to? I mean, the SDKs that are commonly used already do that. I mean, why wouldn't we just say that?
Let me just answer that one. When you mean SDK, do you mean the S3 SDK? Because other object stores, like let's say I want to talk to Ceph backend, not the Rados gateway. That's a very different SDK, right?
No, it uses the AWS SDK.
No, it's a very different. It's not S3 compatible. It's their own API, and then OpenStack Swift is its own API.
But the application doesn't care.
Huh? So
let's simplify for a second. Let me ask you a very simple question. First, should the application define what kind of authentication mode it supports or not? I think Guy and Ben are saying it's going to support multiple anyways. So the application never has to specify it in, say, the bucket spec, bucket request.
I don't think it's application. I think it's the SDK, and we can already say
sure. No, but it's coming from the pod side. When I say application, right? I mean it's coming from the pod developer or admin.
Right.
Let me put it that way.
Spec.
Will the developer specify what kind of authentication model their application is going to need, or is it something that admin kind of mandates top down?
I'd say the latter.
Yeah, me too.
It's the system that supports one or more things and exposes according to certain rules or whatever, but it's not an app who can dictate what it wants.
And if you have the app image too old to support something new, right? The admin enforces, that should break. That makes sense that you have, your application is too old.
Fair enough. Okay. So that means, so the admin needs a way to say this is the allowed authentication methods, and the application doesn't have to say anything. The application simply just starts up and it tries to do things the way it knows. Like, let's say it tries 3 different styles of authentication, and if one of it works, sure, it goes ahead and works. Otherwise, it just fails.
So I agree with all that, but it's incumbent on us as the Cozy spec writers to say what the minimum is, so that if someone else wants to write a compliant workload, they know what the minimum they have to handle is, and have to test, etc.
But how can we define that minimum? Because then you're at the same time also saying that whichever storage system tries to be Cozy compliant must support that minimum.
It's exactly what I'm trying to avoid.
No, it doesn't. It doesn't have to
That's
support
even
it.
like a problem to
The
me.
workloads,
wait,
the
hold on. Why are
workloads
we
have
trying
to
to avoid
support
that?
all of them.
Right.
The drivers only have to support one of them.
Right.
But no, that's not gonna, because the customer won't be happy if their backend doesn't support that.
No, the customer doesn't know. I mean, the application will load whatever
Yeah,
it gets from
the
Cozy.
application is going to run. The
No.
admin can choose a Cozy driver based on what authentication mechanisms the Cozy driver supports. So a Cozy driver, excuse me, that has very minimum authentication styles might not, excuse me, might not be very popular in practice, but yeah, it's just a choice that the developer of the driver makes is what they can support, and then the admin chooses it knowing what it can support, and then the workloads are forced to support all of them, so it just works.
I don't think it'll probably be that the workload guys are going to force the admin to pick the storage system, right?
Why do they care? I mean, it's S3 at the end of the day, right? S3 is S3. Like whether you access it through a secret key or a token, like it's the same thing.
Well, that's what I wanted to confirm. And this is what I said before. Are we talking only about S3 or are we talking about object store and period?
Well,
It's two very different things.
So we are distinguishing between different protocols in Cozy, and then what I'm trying to say is for the S3 protocol, we will mandate, authentication styles A, B, and C, or A and B, or whatever, some minimum that are required for S3. And then if you have a different protocol like Azure Blob, it might be a different set, and it might only be one, but it could be two or it could be three. But the reason that all of this matters for us is because we have, at the end of the day, it's our job to marshal the credentials into the pod. Like that's something we have to do. We have to set an environment variable, create a file, add a parameter, to do something to get it in there. And we have to write down in very explicit terms exactly what we're going to do, where we're going to put each thing, how you're going to know what you're getting, so that we can deal with all those impedance mismatches between us and the actual SDK.
Yeah, and now I agree with what Guy is saying, because he's saying we're talking about S3 specifically. That's what I wanted to make sure of.
No.
That,
So this
GCP has the same, right?
GCP has the same thing.
The Google Storage APIs would have the same mechanisms. I mean, they're copying everything from each other. It's not anything unique here, right?
It's true.
You mean GCS?
Yeah, GCS, Google Storage. Sorry.
But it's also not as if every authentication mechanism requires Cozy to expose something in the pod, because that's where this what is it, 169 dot something magic IP address that you can query in AWS comes from. So we'll the original model of Cozy, where there is the provisioner which creates a bucket and then creates a mint key pair somewhere and then exposes it into a pod, doesn't really.
But Nicholas, this is another mode.
For two reasons. One, in this new model, there is no key pair or whatever to be exposed in the pod. It is already available there magically. Secondly, there is an issue with authorization, because all of a sudden the workload is tied to a particular key pair or whatever else, but it's up to the provisioner to make sure that this workload, that key pair, has access to a particular bucket where that key pair has not been created by this provisioner. So how does the provisioner know which user or which key pair will be exposed into the pod in which the application will run?
Okay, so to answer your first question, so we're going to support the access key, secret key still, Nicholas. This is the additional mode of authentication we're talking about, and we need to support this for environments where higher or more secure styles of authentication is required. Access key, secret key is not going away; it's going to be there, but we need to also support other styles of authentication. Now, your second question was about how workloads simply just get an identity and authentication or authorization just based on like a metadata service, like you were mentioning. Even in that case, I don't think we're introducing a metadata service. What cloud providers do, or what So if you're an Amazon environment, the way you get a particular pod to authenticate as a particular identity is the SDK takes a token from the local file system and then talks to the link local IP address with that as the identity, and then the link local IP address, based on whatever token is presented to it, will say you've been authorized to do this and that. So there is there is still a token that needs to be present into the pod.
Yeah. What I was going to say is I don't believe in magic. That there is no magic. We have to explain exactly what the client or the workload should observe, in all of the different situations. And the answer can be that you need to go talk to something else, but then we need to specify what that is and how you talk to it, and what if anything we're providing for that conversation. Because there's still the step where Cozy has to grant you access. We don't want to have a situation where workloads that haven't been granted access can still somehow get at the bucket because they know how to talk to a thing, right? There's still something we have to provide to enable the access with a given BAR or BA or whatever we're calling it, that's bound to a BAC and all that other stuff, right? Because we want to have read-only access, we want to have read-write access. We in principle might have more complex levels of access defined by other BACs. And so we want to make sure that the workload is being bound to the right level of access that Cozy has given it. And I still think there's credential minting going on somewhere, even in these modes where you're using the token. There's still an explicit call to grant the token access to a bucket somewhere with a certain level of access.
Okay, so I think last week we had the discussion going in the right direction, and I want to bring it back there. So let's again try and answer this question of who gets to define what kind of access they want. So in case of PVs and PVCs, in the PVC definition, we say, hey, I want read-only access or read-write access. And we also expect that, well, rather than even read-only or read-write, let's talk about read-write many. So if there is a workload that expects read-write many, and if the driver doesn't support read-write many, what happens? It's not portable, right? Like if you're moving from a driver that supports it to one that doesn't, it's not portable, right?
Right, and it's generally understood for read-write many that is the case.
Right. So we can give people that expectation of the object storage or Cozy, can we not?
But you would want to have a fallback alternative that is understood
Access
to be generally portable.
Yeah.
So that for someone who wanted to write a maximally portable workload, that they would know how to do that.
Yeah, access key secret key will always be that mechanism. So what if we were to say?
But I mean, the thing that where I don't agree with that is an admin may decide they don't want to enable that. Right? Like we're talking about like the people that care about these credentials in the cloud. Like Google might say no access keys, no secrets in GKE potentially, and then that means access key secret key is not portable to Google Cloud anymore.
So wouldn't that be in the class then?
Yeah. No, wait, hold on. See, admin is supposed to know that the admin is supposed to make sure that you're going to another environment which supports the same protocol. The admin is the one that mandates.
No. The admin is creating the Kubernetes cluster. The user is deciding to use the Kubernetes cluster.
The admin also decides what Cozy driver runs there.
Yeah, so and the class too, right?
And you're right, and how to define it. But I mean, if we want to give the admin the freedom to say, we're not doing access key secret key here, the only way to do that and retain portability is to require all workloads to also support some other authentication mechanism, which is where I'm trying to get us, which is to say there's some minimum set that everyone has to support.
No, yeah, I agree with that. I think what I'm trying to say is that, let me know if this is correct, Ben, is that the admin can say this supports tokens only. Right. Yeah, exactly. Yeah. And then that forces the application writer to understand that. But if we, and we're very explicit to say, when you get this this model of authentication in the class, this is what you're going to get in the pod internally. Is that
Yes.
right?
Yes.
Okay.
Yeah, that's our job, is to be explicit about what we're passing down.
Okay. That makes sense to me.
Okay, so what is the division of responsibility now? Are we saying that the developer specifies what exactly they want, and the admin says this is the
No,
list of things you can choose from?
Yes.
I say that Cozy specifies the minimum that everyone has to deal with. The application just has to take what it gets, and then the admin has freedom to configure his driver and his BCs as he pleases.
Is it if what is the benefit of Cozy doing the least common if the admin can still choose? Is it in case the admin doesn't
But
choose anything and it goes
it's
to
not the
default?
least common. We're defining like a sub or a set of authentication mechanisms everyone has to deal with, which
Right,
is presumably whatever the off-the-shelf SDKs already know how to deal with. So it's not a burden for the application developer to deal with them all if they're using an off-the-shelf SDK.
Yeah,
and then
sorry, I'm not really asking. I'm asking is if the admin is in the middle choosing which authentication model we're going to choose, is it that if they don't choose, we have a default? Is that what it is?
Oh, I would say the driver would get to choose. It's ultimately up to the driver to support one or more things, and it's a driver configuration question of what you actually get.
Okay, so if
we want to have a portability story for a given protocol, no matter what, and that's where this is coming from. If you didn't have one method of authentication that's supported by all drivers for a particular protocol, then portability is out the door. You're not really portable based on protocol. So that's where Ben is coming from. We're saying no matter what driver it is, make sure they all support access keys and secret keys. And then if portability is
no, I said I don't think you're representing what I'm saying, right? The drivers can support just one, and it doesn't all have to be the same. It's the workloads that we're putting the requirement on to support all of them.
Okay, so are you saying that we can have drivers that don't support access key, secret key? Because
I think that, yeah, if we say for any workload that's consuming S3, you have to be able to take a token or an access key, secret key. So like this is a minimum requirement for every workload. Then I don't see any problem with the driver saying, you know what, we're not going to support access key, secret key. We're only going to support token because we know that every workload in the world that does S3 can take that. And so that's all we're going to supply.
Right. For a particular protocol, yeah.
Well, for a particular driver, like a driver that supports the S3 protocol could say we're only supporting token-based authentication. And if the workloads are following the minimum standard, like that shouldn't break anybody. And then another driver can say we're only going to support access key, secret key. And then a third driver can say, you know what, we're going to support both and let the admin choose which one.
The problem is, we might not be able to orchestrate it, because we also have to orchestrate all the different authentication mechanisms now.
We have to support a list of our own choosing that is wide enough to give people portability. That we get to define the list, and we can make it exactly what the S3 SDK supports if we want. We could make it longer. We could make it short. Well, we couldn't make it longer. We can make it shorter.
Can I just want to ask because so I just feel sometimes we're going round and round. Can we be clear? Can we write it down so that we can see it and we will say yes, that's what we want?
Yeah, it's probably a better idea. Let's do that. Let me share and let's write down a simple bucket access YAML. Let's see what that looks like. So whatever.
All right, don't worry about that stuff.
Yeah. And let's just go to spec directly. Okay, so this is kind matters here. So we're calling this bucket access. So a guy, you might have missed this, but we're moving away from the request and access or a request and equivalent cluster scope resource. Instead, we're calling the previous bucket access, the one that was used to request a bucket, we're calling that bucket claim, similar to persistent volume claim. And bucket access is just a single resource. It doesn't have an equivalent in the cluster scope. And this is namespace scope, and this is to request credentials. So here you would just say bucket access class, and anything else that need to be specified here. So this is what goes into the pod. So into the pod, you'll say, let's say we're introducing a new field, or say for now it's an annotation. You'll say bucket access class or something, bucket access ABC. Some mechanism. Let's just say, bucket. This doesn't matter for this discussion. Then we have the bucket access class. And this will have name XYZ. And so what Ben was saying is, Ben, are you saying that here we specify, authentication models?
No, I'm saying that it's a driver specific thing. As long as the driver supports at least one of the ones on the minimum supported list, everything's going to be fine.
Are we creating a cozy driver object?
Could. I mean, we did this, the CSI guys did that because, but that was mostly because of deficiencies in the actual CSI gRPC, where they needed more information, and they created a side channel for providing additional information to Kubernetes outside of CSI proper.
Oh, I see. So we don't really need it, right?
You don't need it if we define our RPCs comprehensively.
I mean, you could, say that can the admin use this resource to specify what all?
No. I mean,
no,
the CSI driver object in the CSI land is not defined by the admin; it's defined by the driver. There's always some driver specific configuration that's part of the, when you install the driver, you tell it how to behave. That's where these kinds of decisions would go. So, if you're using a driver that has more than one authentication mechanism, you would tell it which one you wanted it to use when you installed it, and then it would tell Cozy which one it was choosing to use.
Okay, so do we need a Cozy driver object?
We don't need one.
Yeah,
it's like an escape hatch that we could add for ourselves if we wanted, but it's not necessary.
Okay, so the driver is going to be able to specify somehow. Let's say driver capabilities. In the gRPC response, it says, hey, these are the capabilities that I have, and it gives you these.
Except it won't be a list, it'll just be the one that got chosen. Right?
How do they choose it? So somehow the driver chooses.
Right. For some drivers, it could be hard coded. For other drivers, it could be an option. But it's going to be one, and the driver's going to tell you what it's going to give you at runtime. And then Cozy needs that information so that if it's getting an access key secret key, it knows how to receive that and plumb it into the pod. And if it's getting something else, it knows how to receive that and plumb it into the pod. And we're telling the pods, you have to support either one. So that gives us the freedom to give them either one, which gives the admin the freedom to make these kinds of dictates.
Okay, so let's say the driver allows these three. Okay, just walk me through the scenario. So the driver allows these three, and the admin, how do they specify that they only want to allow IAM based? How would they be able to do that?
It would be in whatever, like, let's say I'm using the Google bucket driver, whatever it is. I don't work for Google. I don't know how it works.
Yeah, no, okay.
Well, okay, let's say it's the NetApp one, right? I know more about NetApp. So let's say NetApp releases some Trident driver that supports Cozy. when you set up your driver configuration in Trident, you'll say, oh, I'm going to choose the token method. And then Trident will begin telling the Kubernetes or the cozy sidecars on the Kubernetes side, hey, you're getting tokens. And if I select access key secret key, then it'll tell them, hey, I'm giving you access key secret key.
So this is chosen in the driver while launching the driver, right?
Yeah, through some the driver internal configuration,
Okay.
which is up to the vendor to implement however they want.
Okay. Okay, and then the workload does not specify anything about what it wants. It just the bucket access class doesn't have any specification about like what among these it's choosing. It's just implicit. That's what you're saying, right? Throughout the process, it's implicit which one you get, and the expectation is the application has to allow all three.
Yeah, and this all rests on the idea that it doesn't ultimately matter. That in terms of what the application
I'm not
can
sure
do,
this will work.
it just works, right? Like
the
bucket access classes should be about.
What does the application know? Like which one it's dealing with? Just checking that all the time.
It's got to be part of our downward API that we tell you when the pod starts up. Here's your bucket. Here's the kind of authentication information we're giving you, and here's the information. Like all of those things have to be provided in our downward API to the workload, and that's why I'm so insistent on like being precise about this, is because that's our biggest job, is defining that particular API that the workload sees from us. You know, so here is your bucket definition. It is you're using access key secret key authentication, and here's your access key, and here's your secret key, or you know, or whatever else we're telling you need to use.
I have a question here. Like, say if we are trying to inject everything to the application pod, like for access key and secret, it's just a file, right? If everything is file, then it's fine. But if they want to inject something else or something, like some IP information, like the service endpoint which IAM need to talk to or something like that. Like if everything is file based, then it's fine. If something additional need to be done, that it may affect the port to come up, right, or something like that.
Yeah, I want to get into detail on let's do some examples of an IAM based authentication scheme, because I'm not too familiar with how that actually works in practice. I mean, I can imagine how it might work, but we should go through a very specific example of, like, I'm running in GKE, I have a Google, account token, it's being plumbed into my pod through the normal mechanism, and how do I take that and turn around and talk to a GCS service with it? I don't actually know the answer to that, but I
actually have a Kubernetes cluster running in AWS right now. We can try it out. So this is running in AWS. I can log into one of these nodes, and
you can just start up a BusyBox pod or something, and then shell into it and see what you can see.
Yeah, so you can curl HTTP 169.254. 169.254. There you go, and then choose say 1.0 and metadata. There you go. So you get this is the metadata you get. Local IPv4, public keys, reservation IDs, and so on and so forth.
This is the metadata you get in AWS.
In AWS, yeah.
Right. In GKE, it might look different, right?
The protocol looks different in the sense the API looks different, but the information is pretty much the same.
Well, but this is where we have to be precise, I think, where we have to say, like, if Cozy is telling you it's
there it is. There's instance identity.
It's IAM.
Yeah, this
then,
is instance identity.
Then these are the exact files that you can these are the exact URLs that you can go consult to get the rest of the information you need.
So Ben, if you're going to make this happen, right, we'll need to run a link local service, and that's going to,
so this is the whole thing, right? If we require that clients can deal with anything, then anything other than access key secret key becomes the problem of the Cozy driver to sort out, right? If the cozy driver says all I support is access key secret key, then no one cares about a metadata service. If the admin wants to install a cozy driver that does the IAM based authentication because they are GKE and they're using Google storage and they want to just do the nice thing, then it's incumbent on them to sort out all of the details so that when we say here's your IAM identity and these are the URLs you're going to go talk to, that it actually works, right? It's not our problem.
No, this is a link local service, so we can't run a link local. This IP address 169.254, 169.254.
Yeah.
Every switch routes it internally to a particular node. It never crosses the switch boundary. That's why it's called link local.
All right. I understand how the metadata services work. What I'm saying is, it's not Cozy's job to deal with it. It's what we do is we tell the workload, if you get IAM, then this is what you're supposed to do to make it work.
Right.
We give driver implementers the freedom to not support IAM if they don't want to deal with any of that.
Exactly.
And if they do want to deal with it, the rest of it is their job to figure out.
Yep. Agreed. Okay, so I think we agree on that.
Cozy still need to inject something, right, based on the authentication mechanism, or like.
Right. What we would inject is like the authentication type is IAM, and then maybe some additional URLs that like, here is how you go get your IAM stuff. And that would be where and that's just a proposal. Like, I don't know if that's the best way to do it, but it's our job to just give you something that is going to be consistent across every possible implementation of IAM authentication. That has to be, compatible with Microsoft and Amazon and Google and Huawei Cloud, or I don't know how many others there are out there, but we want to have a scheme that is flexible enough that it works everywhere, but at the same time, workloads know exactly what they're supposed to do, and there's never any magical incantation you have to say to get your
okay, let me ask
token.
this: should a workload or should an admin be able to? So with the current model that you've proposed, Ben, we have a mechanism for the admin to mandate that this is the only thing that I want. So and they do it through the configuration of the driver itself. That's our current model so far. What we've spoken. Is that a little restrictive? What if the admin
it's restrictive for the workloads only, right?
No, let me put it differently. For the admin itself. So what if the admin wants to change their mind and say they want to go from not allowing access keys and secret keys to allowing it in the middle of operations?
Well, they better get us a cozy driver that allows them to do that.
Okay, so they just
and if their cozy driver doesn't, they better go yell at their vendor, right? To say, hey, fix your cozy driver to let me do this.
Okay, so I think I know what you're saying. So in that case, so it's, I think you're saying that it's okay if whatever ability it gives, flexibility it gives is good enough.
Right, but because it comes down to, like, vendors have products and products have features they support, and if the product doesn't have the feature, like, then there's no way for us to force it to exist. All we can do is say workloads need to be able to deal with all of these things so that they can have the best chance of working across all of the drivers.
Okay, so we're still saying, so the application's contract is still not directly with Cozy, but rather with the object storage or the driver, really.
No, it has to be with Cozy. We need to say, like, access key secret key means exactly this. IAM means exactly this.
Sure, that we'll say. Okay, fair enough. Okay, so I think this would work. So I'm just trying to understand. So portability here really means that when the admin moves you from one system to another, that you don't have to change the application definition whatsoever, because the authentication method is completely transparent, or it is implicit in this case, and the definition only still includes just the protocol. So portability will be maintained as long as
people use SDKs that can support all of the authentication mechanisms,
right,
and we plummet correctly, then we're done.
Wouldn't it be better? Okay, so here's my question. So wouldn't it be better if you were more explicit about it, saying somehow we say in one of our definitions, either the class or the access object, the namespace object, we should be able to say, or let me not we should be, wouldn't it be more explicit and less likely to end up in a, you know, error situation if we could explicitly say these are the authentication mechanisms I support?
So I say no, because you're going to end up with two de facto sources of truth, right? The driver is always a source of truth on what authentication mechanisms are supported, because it might just be hard coded to be exactly one, or it might be hard coded to be exactly two.
I see.
Right.
Okay.
And so if you add another source of truth and it doesn't agree with the first source of truth, then which one is correct? I say the driver is always going to win, and so why write it down a second time? I mean, we could have a situation where the sidecar queries the driver, what do you support? And then it reflects that back into the Kubernetes API so that you can see the status that says this driver is using access key secret key. And now you can see it, but the source of truth is coming from the driver.
We could still do that with, you know, we could put that in this, you know, status of a bucket class maybe. Is it valid
classes
or not?
tend not to have specs and statuses. Classes are just objects,
right?
Usually, but
yeah.
you could imagine something like that.
Mm-hmm. Okay, so I think I know where you're coming from, Ben. So you know, we're out of time. Let's continue next week. But yeah, we should figure this out. We should figure out who gets to. I mean, the open question right now is pretty simple. We've not all of us agreed on who gets to decide, um, or I think, okay, actually, I understand what you're saying, Ben, which is how we're doing portability. It's implicit. As long as the driver supports what the application expects, it's all good.
Well, and the other thing that we didn't talk about a lot today is protocols, right? Luis raised the question of what if it's not S3, and it's like, well, then it's a whole other ball game. So we should go back and say and spell out, you know, how you say you want S3 versus GCS or Azure Blob or a different, entirely different protocol. But then yes, once you've said I want S3 and that's agreed to, how you authenticate to the S3 service is more of an internal thing that doesn't show up in the API. It's just the workload has to support all the S3 authentication mechanisms that we say they do, and the driver has to support
it. I'm telling you, I'm worried about that actually, because if we go down this path of trying to support all the different authentication mechanisms by all the different providers, you know,
it's going to be a list that we come up with. It might not be all of them, and in those cases you can't use those other ones with Cozy unless well, expanding the list would be hard.
Okay, so yeah, let's let's continue next week, and I want to figure out I want to figure out what authentication, like I want to see if we can keep authentication mechanisms abstracted away from particular data protocols, if that's even possible. I'm worried about implementation complexity now.
I don't know if that's possible. It's a good point. Yeah, having to well, I expect for a lot of them the list is going to be just one.